Okay, let's move on to talk about scan processing. As you may remember, our model manager can have one or many result objects. We also have an input data object. Inside this object, we have several groups which can contain entities. We can add data to this object by using the import button or by just dragging some data onto the screen. So let's go ahead and grab some scans that were taken from a structured light scanner and import them. Alright, as you can see, our data has been imported. It's all closely aligned, but we want to find a line and merge this data set. So let's go to our Scan tab. There's a couple ways to go here. We can use the Mesh Buildup Wizard to walk through a several-step process to get a closed mesh, or what we can do are use some independent processes, such as manually edit the data we want to keep, align between my scan data sets, and then triangulate and merge, and then we can whole fill and move on to other operations. So first, let's go ahead and delete the data we don't want. So we'll just square up to it and select an area. But as you can see, it didn't select everything. What we want to make sure is that our visibility filter is set to 3D. So let's go ahead and select one more time. That selects all the way through. We'll go ahead and press delete. Alright, now that I have the data, just the data that I want to keep, I'll go ahead and align between my scan data sets. So here what I'll do is expand this up a little bit. And I'm going to choose global and fine, because I actually know that everything is pretty close. I'd like it to just optimize the positions. And I'd also like to update the histograms, which will be displayed over these images, so I can understand exactly how fine the alignments were. I can set one scan as stationary and set the other moving, but in this case I think I want to set all of them as moving. We'll go ahead and choose the sub-step of apply. Now, just like Design X, we have major steps in our inset window and we have sub-steps. The major step will actually execute the operation and close out. The sub-step will allow us to iteratively try again and then try again if we want to refine the alignment. Why would you want to refine the alignment? Well, we've got a whole bunch of options here on how to constrain the alignment. Constrain motion and axes, constrain how much data is being used or how many iterations, that kind of thing. So what I want to do is choose apply only small transform because I know the data is very close, and I'll go ahead and accept. So you can visually see the histograms are available, and also there's kind of a speckled quality to the data, which shows me that all the data is roughly inhabiting the same space. That means they're all very well aligned. So I'll go ahead and accept the major step, align. Great. The next step I'm going to choose is triangulate and merge. So I'll go ahead and say preview. We'll take a look and see what the quality is like. All right, so we have one merged data set. Looks okay to me. I'll say okay. Now from here we can move on to fill holes, defeature, remove targets, do any sort of scan processing that I want. But I actually want to just move this forward into a result as if we were going to start working with it. So in the case that you have multiple scans that you want to work with, and you finally created a scan that you're going to move forward with to use in an inspection, we can simply select that mesh, right click and say add to result 1. So what's happened is if I go to the result object, minimize some of these things, you see I have a measured group, and I can drop down measured data. There's my captured mesh. And if I move between my input data and my result data folder, you'll notice that each one of these are separate spaces. So I can turn off my visibility here, and this will remain here. So now that I've got a mesh inside here, I can import a reference or align this mesh to a coordinate system and start making measurements on it.